Greetings, everyone, and welcome to the Scientist Saturday edition of CMNH at Home. I'm Rob Huber, a museum educator at the Cleveland Museum of Natural History, and I'm joined today by Dr. Yohannes Haile-Selassie, Curator of Physical Anthropology at the museum. How are you today, Yohannes?
Hi, Rob. How are you?
Everything is good at my house. I wish I was at the museum, but it's all good here.
Well, same here.
So we're here
But
today.
I'm still doing whatever I have to do.
That's good. We're all working from home. It's nice to see everyone on the video screens. So we're here today to discuss the discovery of MRD. Before we get into some questions and answers, we'd like to show the discovery video. Could you say a few words before we let the video roll about what we're about to see?
Sure. This video was put together as part of a press package about 7.5 months ago when the MRD first publications in Nature came out. And the way the video was put together was so that it's easy enough for the general public to understand what was discovered and how it was interpreted. So I think it gives you a lot of information about the specimen, how it was found, where it was found, and what it meant to the study of our origins and evolution. So I think it was a very good clip that sent a lot of message about the new discovery to the general public.
Excellent. Well, enjoy the clip, everyone. And as you're watching, get on our Facebook Live feed where you can submit questions that Yohannes will answer after the video. Enjoy the clip.
On February 10, 2016, Dr. Yohannes Haile-Selassie, Curator of Physical Anthropology at the Cleveland Museum of Natural History, was at the Amato locality of the Woronzo Mile site in Ethiopia when he was approached by a local Afar with a potential hominin specimen. Upon examination, he identified the specimen as an upper jaw and went directly to where the specimen was found. Within moments of arrival, he found the rest of the cranium a mere 3 meters away.
My first instinct was that these two pieces would perfectly join. I picked up the maxilla and I picked up the cranium and click. Perfect cranium. We decided that we need to sieve. We sieved and picked for 3 days at this place. And whatever we recovered perfectly fitted on the main specimen.
The team found key remnants of the orbital region. The now remarkably complete cranium is the first hominin cranium for the Woronzo Mile paleontological study area and the first from its geological age. The cranium was taken back to the Paleoanthropology laboratory at the National Museum in Ethiopia. Given the name MRD, the specimen was thoroughly cleaned and assembled. A CT scan allowed the team to reconstruct the few missing parts and take measurements of the head, face, and its cranial capacity. The final reconstruction was used to conduct an extensive comparative analysis against all known hominin cranium from the Pliocene between 2.5 and 4 million years ago.
MRD has a mosaic of features, some of which are shared with the earliest human ancestors, while other characters look more like Lucy-species Australopithecus afarensis.
We know how old it is because our geologists have been working hard. They took a lot of samples from the various horizons where the specimen was found, and we also did paleomagnetic analysis of the sediments, and both geochronological age and the paleomagnetic data corroborate in terms of giving us a good idea in terms of how old it is.
These findings, now published in 2 manuscripts in the journal Nature, date MRD to 3.8 million years old and assign the cranium to Australopithecus anamensis, giving us the first glimpse of the species' total craniofacial morphology. This monumental discovery also reshapes our understanding of hominin evolution. It disproves a widely accepted idea of a linear progression of evolution.
So now what we know is the potential ancestor of Australopithecus anamensis and its descendant Australopithecus afarensis actually overlapped in time, at least for 100,000 years.
The discovery of MRD advances the Cleveland Museum of Natural History's role as a global leader in the study of human origins. MRD is perhaps Dr. Haile-Selassie's most significant find in his prolific career in physical anthropology thus far.
Knowing how rare these specimens are when we find it is really rewarding and encouraging to go and find these fossils and communicate what they mean to the rest of the world.
Welcome back, everyone. Truly
Wow.
astounding research going on out there. The Woronso-Mille Paleontological Research Project. Yohannes, can you give us an update about what's been going on at the site since the video came out?
Well, first of all, I have to say that I haven't watched this video clip for months now. And when I watched it now, it just brought back a lot of memories from the day of the discovery. So it's really interesting. So what we've done since its announcement about 7.5 months ago is, as we always do, we went back to the field this year in January and February. And we went back to the locality, MRD, BP1, and did a test excavation in the area immediately close to where the specimen was found. And we're talking about about 0.5 meter thick sandstone, and the specimen was just on top of the sandstone. So we don't really know whether there are more specimens, more elements of MRD still buried in the sandstone. So we have to plan on excavating at least the immediate area for a while. And this year was when we started the excavation. So what we did this year was to excavate about 5 centimeters of sandstone from the top and see if there was anything else, exposed close to the surface. We did not find anything after we excavated about, I would say, about 6 square meters of area. But this is going to keep going every year we go back, because we really need some postcranial elements of MRD in order to talk about how it moved around when on the ground, and if it had any arboreal capability and so forth. So we'll keep working on that for the many years to come. But we also have a lot of work to do on the specimen that we have in hand, because what we did in 7.5 months ago was just publish the initial announcement, our initial observations, but there is still a lot more to be done on this specimen, and we're planning on what to do first and what follows. So there's going to be a lot of data coming out of our study on MRD.
Wow, well, let's hope MRD is safe in the sandstone over there somewhere. We can find more. So being that MRD was found in sandstone, was this area a lake or a riverbed 4 million years ago? What do we know about the environment MRD lived in?
Okay, so what we have from looking at the sediments around where the specimen was found, we know that the area had some kind of a lake around it, some rivers, and the way we know about this is because the sediments are mostly deltaic and lake sediments. So our geologists have been doing a lot of work in order to understand how big the lake might have been and how extensive the delta sediments were and what rivers were feeding into the lake. So what we know is that, of course, there was a lake nearby, and the geologists have estimated the size of the lake to be about 9 square kilometers, with about 6 to 8 meters deep. And there were lakes, of course, feeding into the lake. So what we have in terms of what we can say about the paleo environment, in addition to knowing that there was a lot of water body in the area, is to look at what kind of plants may have existed in this region. And although we don't have a lot of fossil remains of other animals in the area, like what we have at other localities at Woronso-Mille, what we can say is, based on the sediments, the deltaic and the lake sediments that we have, and some botanical evidence that we have from these sediments, extracted from the sediments, obviously this was an area where you had a lot of water body and some kind of riparian zones following the rivers and so forth. So yes, it was an area with a lot of water and a lot of riparian zone habitats. That's what we can say for now.
Fascinating. So MRD has been assigned to Australopithecus anamensis. Can you say a little bit about how that fits into the family tree?
Well, of course, since the first discovery and naming of Australopithecus anamensis in 1995, the hypothesis has been that Australopithecus anamensis is the direct ancestor of Lucy's species Australopithecus afarensis. So that was one thing that we wanted to test, to see if Australopithecus anamensis was actually the ancestor of Australopithecus afarensis, Lucy's species, in a linear manner, in which case an ancestor would just give rise to a descendant without any bifurcation or splitting. So the hypothesis since those days was that this is a linear transition from Australopithecus anamensis to Australopithecus afarensis. This is what we've been working on for the last more than 20 years now. And what MRD tells us is actually this relationship between Australopithecus anamensis and Australopithecus afarensis may not have been linear. There might have been some sort of speciation around 3.94 million years ago, where a small population of Australopithecus anamensis probably isolated itself from the main population of the group and gave rise to what later became Australopithecus afarensis. Now, we had to reconstruct this relationship based on some specimens that were already described, like since the 1980s, but whose taxonomic affinity was not really well understood. And by looking at MRD and those specimens from the 1980s, what we realized is that those specimens, especially one specimen from about 3.9 million years ago that was found in 1981 from Middle Awash, whose taxonomic affinity was not really clear enough. So when we compared that specimen to MRD, we were able to see that the below frontal, as we call it, is more like Australopithecus afarensis than it is like the contemporaneous Australopithecus anamensis and MRD. So based on that, what we were able to say is like maybe afarensis and its potential ancestor Australopithecus anamensis overlapped in time, because MRD is only 3.8 million years old. And the record that we had for Australopithecus anamensis was from 3.9 to about 4.2 million years ago. So the fact that we have Australopithecus anamensis as late as 3.8, represented by MRD, and the presence of Australopithecus afarensis, represented by the below frontal at 3.9, that clearly shows you maybe those ancestor descendant groups overlapped for at least 100,000 years. So that's a major breakthrough in terms of how we understand the mode of evolution in the earlier part of our evolutionary history. So it is indeed a very significant specimen, and there's still a lot more to learn from this specimen MRD as we keep working on it.
That's wonderful. When we look at species like Ardipithecus, the earlier end of the spectrum, these had opposable toes. Do we know anything about the postcranial anatomy of anamensis?
So the postcranial anatomy of Australopithecus anamensis is known from a few elements of the leg. Well, not a few, but probably one major element, which is the shin bone, that was found not from the Afar region, but from the type site in Kenya, from Kanapoi and Alia Bay. And this tibia clearly shows that it's more like, modern humans, with some primitive features retained by the specimen itself. So the assumption is that Australopithecus anamensis was probably a bipedal. It practiced some mode of bipedal locomotor adaptation. But we haven't found any pieces of the foot. So we don't really know if Australopithecus anamensis actually had opposable big toe like Ardipithecus ramidus, or even the Burtelle foot at 3.4. We have the Burtelle foot, which also had opposable big toe. So we don't really know. But if it had opposable big toe, it wouldn't be a surprise, because even at 3.4, we have early hominin ancestor that had opposable big toe, like the earlier Australopithecus ramidus. So we're going to have to wait and see and find more elements of the postcranial part of Australopithecus anamensis in order to really understand what kind of locomotor adaptation it had. And that's why we're continuing the research in the Afar region, in Kenya, and at places where Australopithecus anamensis and earlier hominins have been found. So for now, we don't really know whether anamensis had opposable big toe or not.
Great. So if both anamensis and afarensis are bipeds, what are the distinguishing hallmarks that separate the species?
Well, first of all, when we say they were both bipeds, we don't have to really think about the bipedality practiced by modern humans. What we're learning now from different lines of evidence is bipedality had all kinds of forms. It was practiced by different ways. And it just, in general terms, we say they were bipedal, but as you've said, Australopithecus ramidus had opposable big toe, but it was biped when on the ground. Australopithecus afarensis, it was not human-like in terms of its bipedal adaptation. So when we say bipedality, yes, they were bipeds, but not exactly the same kind of bipedality. There was like variation in terms of how they practiced bipedality, right? So in terms of distinguishing them, when we don't have postcranial elements like what we have for example, Australopithecus ramidus, we know how to opposable big toe. What we usually look at for differences is their facial morphology, their cranial morphology, and their teeth, try to reconstruct what kind of environment they were living in. But mostly we look at the morphology, right? So what we see in Australopithecus afarensis and Australopithecus anamensis in terms of how they're different, we see a lot of differences in their facial morphology, particularly with the discovery of MRD, and we also see some similarities. So what we've learned from MRD in terms of the differences and similarities between anamensis and Australopithecus afarensis relates to not only the size of the cranium, but also the shape of the face. So what we've learned from what we've done so far is that afarensis and its ancestor anamensis are very similar in terms of the shape of their upper face, like the orbits. The shape of the orbits is really similar. Also, you see similarity in the lower part of the face, but there is a major difference in the mid-facial area, where anamensis had more protruding or prognathic mid-face, whereas afarensis had very vertical mid-face. So those are the kinds of differences that we tried to look at. In addition to like having a smaller cranial capacity in Australopithecus anamensis compared to the average for Australopithecus afarensis. And there are also some fine detailed differences that we see in their teeth, like the canine and some other aspects of the premolars. So that's how we establish similarities and differences among these related early hominin ancestors of ours.
Awesome. We had a viewer, Jen, asking what postcranial anatomy is. Could you describe for the viewers what that means?
Postcranial means elements that are below the neck. So cranium, and then everything below it is called postcrania. So the anatomy is the shape and form of the specimens, the elements of the body that we see.
And we have another question. Viewers want to know if these two species would have reproduced together and what that means for the evolutionary timeline.
Oh, well, that's a very hard question. I wouldn't say they didn't, especially if they overlapped in time and space. But as scientists, there is no way that we can actually test that hypothesis, right? Because if Neanderthals and modern humans interbred like as late as like 30, 40,000 years ago, we can only say there is the potential that they might have. But if they would produce like a viable offspring, that's a different question. We don't really know. And I don't think at this point of our knowledge, of our technology, I don't think we can find out whether these two early human related ancestor-descendant species had actually reproduced. We don't really know.
It's a great question. Thanks for sending it in. Matt, would you be able to cue the exclusive drone footage? We have some drone footage that Yohannes filmed partially himself, and it's never been seen before, and it's going to be airing here for the first time. Yohannes, as it's on the screen, will you be able to describe what we're seeing? Kind of take us through the shot?
Sure, I can do that, yeah. Yeah, so this is a footage of MRD where the cranium was found, and you see the people down there still surveying. This is actually from this year's field season in February. So what you're actually seeing is, as the drone goes up, you can clearly see the stratigraphy, the laying over of the specimens, and it's really what gave us information in terms of the exact placement of the specimen that we found. So here you go. There are people down there looking for more fossil specimens. And then you can clearly see the stratigraphy here. And there are more sediments even higher above this. And this is where we were able to actually locate all of the marker horizons that we used to rebuild the stratigraphy at this site.
Just beautiful footage. I feel like I'm in Ethiopia right now.
Yeah, so that whitish band that you see close to the plateau is a tuff that was dated to about 3.76. So that was like the minimum age, close to the minimum age of the specimen, which was found at the bottom of that sequence, to the south or to your left. Back to where MRD was found. Yeah, you can see on the right side on top all the younger deposits. And this is just a general view.
How large is the research area?
The locality where we found MRD is actually really small. We're talking about like about 100 meters by 100 meters, 100 square meters. So it's really small. That's why we don't have lots of fossils other than the MRD and about 30, 35 other specimens from this locality. It's not as big as the other localities that we have in the study area. It was just a patch hidden somewhere that we never surveyed before until the local Afar guy who found the MRD maxilla led us to this place, which led to the discovery of the cranium.
Wow, thank you for sharing that footage. It's just beautiful. Appreciate you adding that for today. Exclusive content here from the museum. So we had a couple questions come in during the video. Mason wants to know if we have any evidence of sexual dimorphism among anamensis.
What we have so far in terms of the number of specimens of Australopithecus anamensis that we've found, it doesn't really give you like a conclusive evidence of high sexual dimorphism in that species. But we have larger individuals and smaller individuals, but you can't really say there was high sexual dimorphism in that species or low sexual dimorphism as like what we've seen in Ardipithecus ramidus. It all depends on the sample size that we have. So in terms of crania, MRD is the first one for the species. We don't have any other crania. When you look at the tibia from Canopoi, it looks like a large tibia. So if you think like that's a larger individual compared to the MRD cranium, you still have no way to actually gauge how much sexual dimorphism there was in Australopithecus anamensis. So in order to say a lot more confidently about sexual dimorphism in Australopithecus anamensis, we still need to find more specimens, both from the Afar Rift and also from Canopoi and Alia Bay.
So Lee's question is, what is the conditions like when you're out in the field at that site? Do you have to bring a lot of water with you, she says?
Oh, definitely, yeah, because we're talking about like 100, 110 degrees of heat, dry heat, of course, and you gotta keep yourself hydrated. So yes, we definitely take a lot of water with us, and that's how we survive the heat.
Super important to stay hydrated while you're working. We have a question from Cameron who wants to know, do we know what drove MRD's evolution, and was it the environment?
Well, MRD as a single individual, we can't say much about what drove that specimen to evolve. But as a species, Australopithecus anamensis, what resulted in its evolution depends on a lot of factors, and environment is always a key factor in all of this. But do we have enough evidence to say that there was environmental change that resulted in the appearance of Australopithecus anamensis in the fossil record? It might be too early to say that, because there could be so many other reasons as to why a species evolves or a species goes extinct. But environmental change has always been like one of the major reasons for species to evolve or go extinct. So that's something that paleoecologists are working hard on in almost all sites that we have.
Exciting. We have a question from Meredith. She wants to know if those drones are used in the research and how are they used?
Well, they have different use for like paleoanthropologists like myself and geologists. And geologists are actually using drones now to actually reconstruct the stratigraphy of an area where it's so complicated, something that you cannot do by just walking it across. So I had to lend my drone to my geologists of the field so that they can record a lot of what they can't really walk physically. So it looks like there is a lot of use by geologists these days than paleoanthropologists. For me, it's like to show, for example, when we're doing excavation, we can have a look at the excavation of like from the air and so forth. But I think it has a lot more use for the geologists out there than it does for paleoanthropologists.
Exciting. We have a question from Renata. She wants to know what your favorite part of research is, Yohannes.
Oh, going out to the field and finding early human ancestors, of course. But now I think as I get older and my eyes get weaker, I'm gonna have to concentrate more on the research and the analysis and support people to actually find these fossils out in the field. So finding fossils would be my preferred thing in the field.
Sounds like the best thing to do to me too. Hey,
Yeah.
we have a question from, I think it's Letitia. Forgive me if I mispronounce. There are many hypotheses regarding bipedal evolution. Which one is most likely according to you?
Yeah, as you said, there has been lots of hypotheses for the origin of bipedality. Some of which could be tested and falsified. Some others very difficult to test. And one of my favorites is probably the one that's really difficult to test, which is the provisioning hypothesis that was proposed by Owen Lovejoy in early 1980s. So obviously, if you have to free your hands to carry food and provision, that makes a lot of sense as an explanation as to why we have to become bipedals. But obviously, there are other theories, hypotheses, like the savanna hypothesis, which was actually falsified by the discovery of Australopithecus ramidus in a more wooded habitat instead of savanna habitat. So if you ask me, like, for my favorite, this is the provisioning hypothesis would be my favorite. But the fact that we can't really test it kind of makes it really difficult to actually go with that. So we keep learning from what we're seeing in the fossil record and test existing hypotheses as we move on. That's all I can say at this point.
Hey, thank you. So John Gertschy did a remarkable job on the MRD reconstruction. What was it like for you the first time you looked face to face at MRD's recreation?
Oh, well, John Gertschy, he's a very famous paleo artist. And when I commissioned this reconstruction to him, I did not even tell him what species it belonged to. I didn't tell him how old it is, because I wanted him to do it, like, blindly. Okay, he knows his anatomy. He knows the morphology of all these early hominins because he's done a lot of reconstruction of these early human ancestors. So no answers from me in terms of how old it is, what it is, where it was found. Nothing. That's how it started, because I wanted to see how he would reconstruct it without having an idea in terms of what it is. And given his deep knowledge of anatomy, skeletal anatomy, especially of the cranium, he really did a terrific job. And when I saw the first specimen, the reconstruction for the first time, I was like, wow, And he as he went on, because I was following the entire reconstruction from start to finish, and I was checking, like, whenever he puts the muscles on before he even got into the skin and hair stage. And I was just following it through, and it was really impressive in terms of how he was doing it, like, step by step, to come up with the final face that we saw for the first time. In terms of, like, we never had any idea in terms of what Australopithecus anamensis face might have looked like, and this is the first glimpse of it. And I was very happy in terms of how it turned out to be. And we can clearly see the differences in the facial morphology that we've seen from the bones. That is also reflected in the reconstruction. And yeah, it's really impressive. That's all I can say.
I know we were all so excited at the museum to get our first glimpse of it when it came back, and it's just a really exciting time. And I also think about when I was in physical anthropology lab and trying to use Play-Doh to put the muscles on a skeleton and how terrible mine looked. John does an amazing job.
Oh, he does. He does.
So we had a question come in from Bladen. Bladen wants to know if Afarensis and anamensis overlap in time and space. Did they live in the same habitat?
It's quite possible. It's quite possible that they shared similar habitats, because it's all about abundance of those similar habitats that we're talking about. Because if they don't have to compete for resources, if there is, like, abundance of similar resources that they're utilizing, there is no reason as to why they couldn't coexist peacefully. So it's all about the availability of the resources that make two related species not be able to live in the same habitat, because they have to compete, and one of them will have to either go extinct so that the other could succeed and so forth. But I think there is no reason to say that two related species cannot overlap, like in terms of their resource use. They can't, I think. So that's how we should look at anamensis and afarensis.
Well, this question looks like you might know this gentleman. James Bright is saying, one of my lifetime highlights was finding a 3 million year old elephant bone in the field with you. Did anybody ever use that thing?
Oh yeah, the elephant remains, like every other animal remain from the site. They have their own information to give us in terms of the paleoenvironment, not to mention like understanding their own evolutionary history. So the elephant specimens from our site were actually published with a colleague from University of Michigan, and we understand their evolutionary history and their phylogenetic relationships, and they also give us good idea in terms of how old of sediments we're dealing with by finding these elephants, and like every other animal. So yeah, elephants are as interesting as the hominins and other taxonomic groups that we're finding from the localities.
Next question is, has there been any work to identify genus Homo at Woronso-Mille?
Oh, so we've been working on sediments that are older than 3.4, 3.3 million years ago. And as we all know, the earliest evidence for the genus Homo is now reported from about 2.8 million old deposits, also from the Afar region at Ledi Gararu. So if we push the record back to 2.8, now there could be a possibility that it may have existed even as early as 3 million years ago. But as I said, we've been concentrating our work on the sediments that are older than 3.2, 3.3 million years ago. But now we've started working on the younger deposits, and we're looking hard to really carefully to look at the sediments that are younger than 3.2 and see if we can find any trace of the genus Homo. So that's what we've been doing for the last 2 years mostly, and hopefully we have some specimens that we're going to study and find out that their taxonomic affinity. But we can't say for sure right now that we have Homo from anything older than 2.8 million years ago.
Well, back to anamensis, Ellie has a question. How far do you think the species spread in terms of habitat?
What we learned from Australopithecus afarensis, which is probably one of the best known early human ancestors that existed, is that these early human ancestors were not really specific about their habitats. So they were able to exploit a variety of habitats at different times. So they were more like generalists who could exploit a number of habitats. So I wouldn't restrict Australopithecus anamensis to a certain specific habitat that it was actually exploiting. It was probably exploiting a lot of various habitats like its descendant Australopithecus afarensis.
Wow. This has just been great, Yohannes. What kind of tips could you share for a young person that might be interested in paleoanthropology?
Oh, well, my first advice is first ask yourself, like, where do I come from? And think beyond your parents, your grandparents, or even great-great-grandparents, because I'm sure like as you go like 10, 15 generations, you're going to be lost. And that's when you're going to start wondering, like, where did this earlier ones that I don't even know about came from? And I think the best thing to do is to go to natural history museums like the Cleveland Museum of Natural History and look at what they have on human origins and evolution. And that gives you an idea in terms of how far you can go back in terms of understanding your origins. And that would be the first place to go to. And then, of course, if you're really interested, you're going to have to, pursue your education in paleoanthropology and get a degree and eventually go out to the field and find the fossils yourself. That's how you can, be a paleoanthropologist.
Oh, that's great. Wonderful advice. Thank you. So we're all being very adaptable at this shelter-in-place time. How are you continuing to work during this time?
Oh, for me, I honestly speaking, I think there's nothing different about what I would have done in my office that I'm not doing at home right now. Because usually when I go to my lab, I do readings of literature and I describe specimens that I have from my site in Ethiopia. So that's exactly what I'm doing here, right? So I have specimens that I'm actually working on right now. A lot of them actually, because they keep me busy at home, and this is exactly what I would have done if I were in my office. I have like lots of specimens that I'm working on right now, and the description, I can do it from home. Catching up with the literature, I can do it from home. So this is what I would have done if I were like in my office, in my lab. The only thing that I'm not doing by not going to the lab, or what I'm doing by not going to the lab, is I'm drinking a lot of coffee now, and I don't have to get up in the morning and dress up to go to work. That's the only difference. Otherwise, in terms of what I can accomplish in my work, I'm still doing exactly the same thing that I would have done in my office.
Oh, well, this has just been great, Yohannes. We really appreciate you taking the time to talk with us today. I know I miss being at the museum, and I look forward to seeing you back there. If
Yeah,
you guys haven't had a
you
chance
too.
to check out Johannes's Explorer lecture, head to the museum's YouTube channel where the lecture is posted. And if you're looking for previous episodes and wonderful education content, go to cmnh.org and look for that CMNH at home link. Yohannes, is there anything else you want to tell the viewers today before we wrap up?
Well, I would say that this Scientist Saturdays programs are really cool programs, and they teach the general public in a lot of ways in terms of what the researchers at the museum are trying to do. So yeah, that's I encourage everyone to watch those programs of the various weekly days of the museum's communication with the general public, and that's all I can say for now.
Well, I learned so much today, Yohannes. I really appreciate the interview. We will be back here with another edition of Scientist Saturday next week, where we're going to have Dr. Nicole Gunter illuminating us about the world of dung beetles. So for now, from everyone at the museum, stay home and stay healthy until we see you guys again. Be well.